Hi, hello, good evening. Okay, um, so let's start. Welcome to week 8 of Data Science for Engineers NPTEL problem solving session. And I'm your TA, I'm Ravalika. I'm a PMRF and a PhD scholar from IISc Bangalore. So, so before we get started, our usual instructions the session is being recorded and be respectful during the session. And if you are not being respectful, I'll not hesitate to remove you from the session. Also, please use Q&A. The chat is still disabled, so uh, just use Q&A for today. Okay. For today, we'll be covering all of these topics, classifications with KNN, and how to implement KNN algorithm. And we'll also see how to use KNN in our studios and what are the different types of learning, such as supervised learning, unsupervised learning, and reinforcement learning. So supervised and unsupervised learning is something that I have told in the last two classes as well. And today I'll give a brief introduction to what reinforcement learning is. Okay. And then we'll go on with k-mean clustering and k-mean and how to implement k-mean algorithm, k-mean clustering algorithm, and also we'll see how to implement that in our studios and how to choose this particular value of k in k-mean clustering. So we'll discuss all of these topics in theory, in code, as well as I'll just ask a couple of questions and try to answer them. Okay. So we'll start. We'll start with classification with KNN. KNN means K nearest neighbors. Okay, so in this, it is basically like it is going to explain the categorical value using majority votes of nearest neighbors. That is, let us say I have a value here, and the closest neighbors belong to class A, and the other side class B, and on another side it is class C. If I'm taking all of these into consideration, I'll see what is the major number of classes which is close by to the value that I want. So in this example, all the A's are much larger in majority. So hence I'll consider this particular data point to be a class belonging to A. Okay. So yeah, it is like this. So as you can see here, there are two classes, class A and class B. Red and star indicates class A and green and a triangle indicates class B. And I have a question mark here. This question mark is a data point to which I don't know which class it belongs to. Okay, so I'll plot them on my x and y axis. Okay, I'll have some values to it and I'll plot it. And then I'll try to find what is the closest, what how many data points are there in the vicinity of that unknown data point for me. So here the unknown data point is this question mark. If I'm taking k equal to 3, let us say that's just a radius kind. I'll just take these three. I'm just getting three data points here. So out of these three, two of them belongs to class B. So when k equal to 3, majority is class B. Then I might say my question mark, this unknown data point is belonging to class B. If I'm taking k equal to 7, I'll just clear this up. If I'm taking k equal to 7, then I'm taking these 3, 4, 5, 6, and 7. 7 data points I'm taking in total, right? So when I'm taking that, I'm having 4 that belongs to class A and 3 that belongs to class B. So when k equal to 7, then the majority is class A for me, right? So like this, we are going to classify some unknown data type based on the nearest neighbors, and that is called as KNN, K nearest neighbors. Basing on the K value, those many number of neighbors we are going to take, and based on that, we are going to classify. So We have discussed linear regression problem last week, right? So in that we are particularly following y is equal to beta 1 x plus beta naught, right? So that is a parametric equation. So in that the parameters are beta naught and beta 1. But in this KNN, we don't have any particular equation in such a way or a function in such a way. Okay, so hence we call it as a non-parametric non-parametric algorithm. Okay, so far clear? Explain null space and basis PCO model in next class. Yeah, sure, I'll cover that. Just a second, I'll just write it anywhere. Okay, I'll explain that. Okay, okay, so far clear? All KNN and non-parametric algorithm. Okay. Uh, And the next part is where we call KNN as a lazy learning algorithm, as it doesn't learn like a general model. So in a general model, what do? We give in some training data. So from the training data, it is going to take the input and it is going to predict some value and it is going to again compare the predicted value to the ground truth. And then based on that, the model keeps learning again. So in this one, there is nothing specific like learning here. It is just going to adjust, yeah, the the data point that is to be predicted to the values that are closer to it. Okay. So in this one, it once we give the data, it is going to take the entire data set. There are no making batches and everything. It will take the entire data set and it will make the predictions based on the nearest neighbors of the new data point. Okay, so in this example, if you see, all the red and the green ones are my training data. So I'm giving this data to the model. It is going to have this particular graph kind where it will put each data point in particular places. And then this question mark here is my the data point that needs some prediction. The prediction to in which class that belongs to, right? So the model is only predicting based on the closest values. So hence there is no learning that is happening here, and hence we call that as a lazy learning algorithm. Okay, and then the decision making. When it comes to the decision making, it is basing entirely on the local data, which is the data which is around the unknown data point, rather than taking the whole data, training data which is available. So, in case when we are training a normal linear regression model, what happens is we are taking the training data set and we are training the model on that entire data set, right? But in this particular canon, there is nothing like a global model. Instead, it is like a local model where it is taking the data which is closer to the unknown data point, like this. So here we are in this particular graph, we are not taking the entire data set when we wanted to find this. Rather, we only took the ones which we needed, right? And because of this, it may it makes a model like flexible to adapt to any kind of complex patterns that are visible in the data. Okay, and yeah, this scaling is really important in KNN. Okay, so if you as a comparison, this is before KNN. I have two categories, all the green ones and the orange ones, and then I'm introducing a new data point, the blue point here. So then I will use some KNN use KNN. I'll maybe put some K value as something, and then I'll try to figure out whether this particular new data point falls into category A or category B. And then after KNN, I'm finding that to be closer to category A. Okay, so this is a basic overview of KNN, right? So so far clear? Okay, cool, thanks. So let us see how to implement this KNN algorithm. Okay, so I'm having a couple of data points. Okay, and I'm having two axes as x1 and x2. So each data point, let us say, if data point is A, it is like x1 comma x2. Okay, and so on. Maybe let us say dash, and then for B is equal to x1 double dash comma x2 double dash, and things like that. Okay, and I'm going to plot all the data points on these x1 and x2 graph. Okay, and now I am having a new data point here, which is this orange one, right? Please repeat. What do you want me to repeat? Um, Please, when you're asking me to repeat, please exactly tell me what you want me to repeat so that I can understand. Because so far I have already covered, I have given the entire overview of KNN. If you ask me to repeat that, that is a 10-minute worth of class again I have to repeat. So you want me to repeat that or just this KNN, whatever I have told till now? If you want me to repeat KNN, I can repeat it completely. It's fine. Intro to KNN. Okay, I'll just give a brief. Okay, I'm not going to go deep, but I'll just give. Uh, okay. So if you can see here, okay. So this question mark is an unknown data point for me. Okay. And all the green ones belong to one class, all the red one belongs to one class. My question is, I have this unknown data point and I have to predict to which class this belongs to. Okay. So if at all I'm taking k equal to 3, I'm taking three closest neighbors that I have around the unknown data point. And then I am trying to figure, and I'll take the majority. So in this particular k equal to 3, the majority is class B, right? 1 and 2. I have two values. So when k equal to 3, class is B, the unknown data point. But in case if I take k equal to 7, I'm taking 7 nearest neighbors and then I'll try to find what is the score for each class. For class A, it is total 4 and for class B, it is total 3, right? So the majority is class A. When k equal to 7, my class is going to be A. Okay, so this is how we usually predict in KNN. So this is also the same. So before KNN, I have two particular categories, category A and category B. I have a new data point again here. And then when I apply KNN, it should either fall into category A or category B based on the nearest neighboring class, like majority nearest neighbors. Okay, so after KNN, it was found that this particular point is closer to category A rather than category B, with more number of neighbors closer from category A. And hence, this unknown data point was assigned to category A. So that is a whole overview of KNN. Is it clear? If you are not clear, you guys can always ask and I can always repeat everything. Okay. Okay, I really appreciate you asking. If you are not really clear, please immediately ask then and there. Okay, just make sure what you want me to repeat again. Okay, okay. So let's start with KNN algorithm. So KNN algorithm means the procedure that we are going to follow to implement this entire KNN, whatever we have seen so far. So how to implement it? What are the steps and all of that? Okay, so let us say these are my data points in overall, and I know that these green dots all belong to category A. All these blue dots belong to category B. Okay, let us say I have a new data point here, which is in orange. Okay, and I'm not sure which category it goes under. Okay, and now we have to figure out using KNN now. Okay, so this plotting of the graph, you already know. If at all I'm calling, okay, let's call it as A dash. If I'm calling this particular point as A dash, maybe it can be of the form x1 dash, x2 dash, and maybe this one is x1 dash and this one is x2 dash. Okay. So based on that, this entire data points are plotted everywhere. Okay. I'll just erase of these. Okay. So for the first step, what we are going to do is we are going to calculate the distance between the new data point and all the label data points. The label data points are nothing but these all the points of green and blue in color. So what we are going to do now is uh, I'm going to take the distance between this unknown data point, this new data point, with every other uh, data point which is already existing. Okay. And so far, for all the data points, we are going to calculate the distance. Okay. So if the unknown data point is A and the known data and another data point somewhere from here is B, then the distance, parameter, the distance that we are going to calculate is Euclidean distance. Okay, this is something that you have always seen everywhere. So it is x2 minus x1 whole square plus y2 minus y1 whole square root over. Okay, you take the Euclidean distance between the unknown data point to all the known data points, all the labeled data points that we have. Okay, from category A as well as category B. For everything we'll take. Okay, and then we order the labeled data points in increasing order from the least to highest. So the closer ones will come first and the farther ones will come next. Okay, we'll order all of them in ascending order, right? And then for the step 3, what we are going to do is we are going to set top k label data points and look at the class. Okay. So then we will assume some k value. Let us say I'm taking k equal to 3, let, for example. Okay. If at all I'm saying k equal to 3, what I'll do is uh, let us say the distances that I got were y1, y2, y3, y4, and so on till maybe y15. I'm not sure how many points are there. If I'm saying k equal to 3, what I'll do is I'll take the first 3 closest values. Okay. If I'm saying k equal to 5, then I'll take y1 to y5. All the values I will take. Okay. So I'll take all of these, all the top values according to my k value. Right. Step 3 is clear or not? We are calculating the distance and then we are keeping all the distance values in ascending order, and then we are taking the top k values, k distance values. Okay, so let us say uh, okay, the point is here. Okay, this is the unknown point, new data point, and this one is a1, this one is a2, this one is a3, this one is a4, and this one is a5. Just saying. Okay. For k equal to 3, we have to take 3 values. Yes. Um, okay. And let us say this is my distance 2, distance 1, distance 3, distance 4, and distance 5. And my order, this is just an example that I'm giving. Okay. It can be anything. Maybe let's say D3 ascending order, D2, D1, D5, and D4. Okay. Let us say if this is my order. And if I'm taking k equal to 3, the top 3 I'll take. Okay, D3, D2, and D1, right? And what are the points for that? The points are A3, data points are A3, A2, and A1, right? So now we will see to in what classes these all belongs to. Let us say A1 belongs to class B, A2 belongs to class A, and A3 belongs to class A. Okay, I have like A, and B. Okay. Now, what I what I'll do is I'll take the majority class. So in this A, and B, what is my majority class? Is it class A or class B? What is my majority class here? Is it class A or class B in this particular example that I'm taking? Amazing. So the majority class here is class A, right? So then what I'm going to do is I'm going to label this unknown data point as class A, right? Okay. Then majority is A here, and hence I'm taking it as and then I'm assigning it as class A. Okay. So in this particular example here, I have the new data point here, and I'm taking k equal to 5, and then the closest 5 are these, and among them, the category A have 3 neighbors and category B have 2 neighbors, and hence we are going to category A. We'll assign this to category A. Clear? Okay. So I'm telling everything at once as a summary. Okay. So first you look at the data. Okay, so let us say this gray point is the data that you want to find. And here there are 3 different classes: yellow, green, and orange. Okay, okay, that's not yellow, that's lime green. And then next what we will do is we will calculate all the distances from this point, and then we will order them in ascending order, closest to farthest, and then these are my first, second, and third, and fourth. If at all I'm taking k equal to 4, then I'm going to see, okay, 2 things belongs to this lime green, and 1 belongs to green, 1 belongs to orange. And the highest number of votes that are there, that is going to be the class of the unknown point. Okay. Um, I hope it's clear, right? Okay. Uh, Do you want to see an R code, or do you want to continue with, like, do you want me to ask questions? Which one do you want? R code or questions? Do you want the R code on KNN questions? Okay. Two are conflicted. I'll do one thing. I'll discuss 3 questions, and then I'll go to R code, and then again I'll come back to questions. Okay? I'll just mix everything. Okay. First, let's discuss 3 questions. What is the primary purpose of the K nearest neighbor algorithm? Sorry, this shouldn't be here. What is the primary purpose of K nearest neighbor algorithm? Is it classification or regression or clustering? No answer. What did we do so far? Did we do classification or regression or clustering or dimensionality reduction? Classification. Yes. Both of you are right. It's classification. In KNN, what does K represent? In KNN, what does K represent? Option A, number of clusters. Option B, number of features. Option C, number of neighbors to consider. Option D, number of iterations. A and C. Okay. Anyone else? Okay. So in this, okay, someone else said something. Okay, number of clusters, number of neighbors. Okay. The number of neighbors to consider. So K is nothing but the number of neighbors to consider. So the K in KNN represents the number of nearest neighbors that the algorithm uses to make the predictions. Okay. It's like, so if we are having a predict unknown point here and A, B, B, B. If I'm saying K equal to 3, then this is 1, 2, and 3. Okay, I'm taking the three nearest neighbors. Okay. How does KNN handle categorical data? If I'm saying I have some categories, then how does it handle? Option A, it cannot handle categorical data. B, it treats categorical data as continuous values. C, it uses specialized distance metrics for categorical data. D, it ignores categorical features during classification. Please don't use Google. No Google, no ChatGPT, please. Okay. So it uses specialized distance matrix for categorical data. So as we have seen in the previous things, we are using Euclidean distance as the matrix, right? So KNN can handle categorical data by using distance metrics like the sorry Euclidean distance, and there are other metrics such as Hamming distance for categorical features. Okay, right? Okay, as I have promised, I'll shift to R code now and we'll come back again for the questions. All right? Share my screen. Give me a moment, please. Okay. So in this, I am loading a data set called as Iris. Okay. So Iris is a built-in data set that is already available in R. So I'm going to load that and I want to see what is there in Iris. So iris has sepal length, sepal width, petal length, and petal width. And then I have something called as species. Okay. So it has some species, three kinds of species, and as we can see here. So we have three types of species: Setosa, versicolor, and virginica. Okay. So I have 50 of each species. So I have total 150 data points with me, right? Okay. So now what I'll do is I want to split this 150 data points into training and testing. Okay. I'm dividing them by 80-20 rate. 80 is to 20 percentage. Okay. And my training data is going to be 80% of the entire data set, and then my testing data is going to be 20%. Okay. And I'm using something called as KNN. Okay, so KNN is a function. In that, telling what is my training data, and I'm also telling what is my testing data, and I'm also telling what is the class that what are the classes, classes that I have. So all my classes are in species, right? Am I going fast? I feel like I'm going fast. Just give me a minute. Okay. Am I going fast? Please let me know if I'm going fast. Okay. So we'll just continue. Okay. I'm having the training. I'm declaring what is my training data. I'm declaring what is my testing data, and then I'm also declaring what is the classes that I have. So in training data, the species which are there, that is my training data, right? So the total k value that I'm telling here is k equal to 3. Okay. And then for KNN in general, what we do is we take something called as a confusion matrix that we have seen previously. Now we have 150 data points, and keeping all the points here is only going to clutter up everything, and you won't be able to look at the plot properly, right? So now what I'm doing is I'll have this confusion matrix. I hope you all remember confusion matrix from the last week's class, right? And I'm calling the model, the KNN model, and then I'm telling this is my test data and these are my species. Okay, and then I'll get all my. This is the confusion matrix. So this horizontally, it's the reference, that is the true labels, and vertically, if you see, that is the predictions. So when the reference, the original data set is setosa, the prediction by the model is also setosa. Then for out of 10, it is giving 10 right, right? And when it is versicolor, it is also predicting versicolor out of 10 times. Okay. And when it is Virginica, it is telling 9 times out of 10 that it is Virginica, but one time it is saying it is versicolor. So there is one particular false error it gave. I mean, sorry, it the one time it has predicted wrong, but rest of the time it has predicted absolutely right. Okay, all these predictions are made based on that nearest neighbors only. Okay, so because of this one thing, now our accuracy is 96.67%, right? And then all the sensitivity, specificity, and positive predicted value and negative predicted value. So all of these formulas and everything were discussed in the last class. I hope you all remember it correctly. And these all with respect to each class, Setosa, versicolor, and Virginica. Okay, clear? Is it clear so far? Okay. Okay. Then I'll shift back to learning again. Just a second. This is this for 3 cross 3. Yeah, we have three classes. So the confusion matrix will be 3 cross 3. Yeah, yeah, but we okay. Okay, I'll explain it everything like for each class also we can do. I will explain it at the end if you want. Okay. Okay. Uh, okay, let's go back to our questions. In KNN, what distance matrix is common? Oh, am I sharing? Yeah. In KNN, what distance matrix is commonly used for continuous numerical features? We have done this just now. How will we choose which which one is true positive? True positive means okay, I'll just write it down here itself. Let us just call it as A, B, C, right? So how did we have it? Like 10, 1, 9, 0, 0, 0, 0, 0. So this was a confusion matrix that we got, right? This was a confusion matrix that we got now. So with respect to class A, the true positives are when it is A, and true negatives, in case if there are values here, it is going to be okay. Okay. The true negative, there are no negatives here. Okay. So that is going to be zero. If this is reference and this is predicted, right? The other ones are going to be the wrong answers, right? Obviously. So these values are going to be the true positives with respect to their each class, and the other ones are going to be the negatives. Uh, there are no true negatives here. And false positive for B. Okay, if at all we are taking for class B. Oh, sorry, class C. Class C, right? So for class C, the true positives are 9. But when it came to this negative, that is the wrong value, that is 1. It is making a wrong prediction, right? Then you, in case if you are having multiple such things, what you can do is you can simply add both of those values. Okay. Okay. Let's get back to this. So what matrix is used? Euclidean. Option A. Yes, you guys are right. The distance matrix for continuous numerical features is always Euclidean. Okay. With respect to class C, I don't say it is false positive. Uh, it will be false. Oh, wait. Yes, you're right. False positive. Okay. Okay. Let's get back to the questions. What is the curse of dimensionality in the context of KNN? Okay. So in case if we are having less number of data points, let us say I'm having 10, then it is very easy to compute. In case if I am giving you 1,000 data points and I'm giving you one single value and I'm asking you out now among these all the 1,000 points, I'll ask you to calculate the distance and then make it in an order and all of that, right? So what is in this whole process, what is going to be the curse of this dimensionality? C, right? Increased computational complexity as the number of features grows. So features here in the sense x1 and x2, we just have x1 and x2, that's fine. But if I am saying if I give you more than x1 and x2, if I'm giving maybe x1, x2, x3, then you are it is going to be much more difficult for you, right? Okay. You are using KNN for a regression task with K set to 3. The distance to the nearest three neighbors are 2, 3, and 4. What will be the predicted value using simple averaging? So there'll be times where you are not required to take the most closest one, but rather you have to do averaging. Okay. Then what are you going to do? You just take the average of all the distances. You just take the average between 2, 3, and 4. 2 plus 3 plus 4 divided by 3. 2 plus 3 is 5, 9, 9 by 3 is 3, right? So the answer is 3. Okay. Okay. So before we discuss about different types of learnings, I just wanted to ask one question. Now we have seen about KNN so far, right? So according to you, what is KNN? Is it a supervised learning or unsupervised learning? Is KNN supervised or unsupervised? Okay, one person says unsupervised. Any other answers? Okay. So, so far what we have done, KNN, is actually supervised learning because when we are saying I have points like this and all of this belongs to class A and all these points that belongs to class B, basically I'm having labels, right? I'm having labels to them. Based on the labels only, I am predicting the new point that I am adding here, right? Supervised learning is data that is there along with labels. Okay. So if for data point one, I'll say it's class A, and data point two, it's class A, data point three is class B, and things like that. Based on the labels only, I am predicting the new data point. Okay. And hence that is a supervised learning. When there is no data point, sorry, no label, like if I'm not having this A and B, I'm just giving you a graph which is a clutter like this and a cluster like this. And I'm not saying you which is what. Okay. That is going to be unsupervised. This is supervised. Okay. So let's look at supervised, unsupervised, and reinforcement learning. Supervised is something that you already know so far. You have data with labels, right? And then uh, you have this a model for supervised learning. You have a model. It will give you some predictions, and then you go back and you calculate the error, and the model you will give the error to the model, and the model again learns it back. Okay, this whole process keeps on happening. And once it is done, it will give you some output. It will give you some mappings to the class, right? The mapping is in this way, right? If I'm having A, B, C, I'll get some from somewhere, from some other neurons. I will get all of these, right? Some mapping will happen and I'll get the final answer based on the probability, the highest probability, and all of that, right? So that is supervised learning. You all know supervised learning. And then comes the unsupervised learning. Unsupervised learning is the learning that happens in absence of labels. Okay. So the easiest example is the one that I have told before. which is this. I have two clusters and I don't have labels. They are just in a particular cluster. Based on this, I can say this is one whole group, this is one whole group. Just by looking at it, right? So that is an example of unsupervised learning. I can group them into classes. And then comes reinforcement learning. So in reinforcement learning, what happens is the system will do something. Okay, it will do something. If it is doing right, then we are going to give some reward to it. We will evaluate and we will reward to it. It's like uh, training a dog. So I'll just say a dog to jump. If the dog jumps, I'll give him a biscuit, right? So the reward here is the biscuit, and I'm giving him some training and like jump or just roll or um, just go fetch the ball. I can say something. If he does it right, I will give a biscuit. I will. The evaluation depends on me. So the output to that is an action. So the actions here are jumping or going and fetching the ball and things like that. Okay, that is reinforcement learning. And exam anyone wants to give examples for supervised learning, unsupervised learning, and reinforcement learning? Good examples. Anybody? Something that we haven't discussed, or okay, it's okay. We have discussed also. One example from each type of learning. Don't use Google. Please say whatever comes to your mind. Okay, fine. Then I'll only give some examples. I have written some here. So in supervised learning, the first one is spam mail clustering. So if you open Gmail, then you will obviously have these folders, and in one of the folders we have spam, right? So whatever the system thinks that the mails are spam, that is like unnecessary or just marketing and all of that. So then they are automatically thrown into that folder, right? And then unsupervised learning is an example for movie recommendations. So if I want to predict if the movie is hit or a flop, okay, I will see, I'll read the reviews, right? Reviews written by critics, movie critics. And then I'll decide like so if I see a word which is terrible, then I'll obviously say okay, terrible means it is a flop movie, right? So but I'm not specifically telling it that the movie is a hit or a flop. I'm just asking the model based on the reviews. You tell me that it is a hit or a flop. Okay. So that's an example for unsupervised learning. For reinforcement learning, the example is a self-driving car. Okay, the Tesla cars and all of that. Right. Uh, so before we go to K-mean clustering, we'll just take a 10-minute break. Okay. Let's be back by 6:58 exactly. Okay, there is not much to cover. We can finish it off fast and then we can go to our studios as well. Okay, let's take 10-minute break till 6:58. Okay, exactly at 6:58, I'll start it again. Okay, so let's start. I hope everyone is back. Okay. So let's start with K-mean clustering. So far we have seen K nearest neighbors, right? So that is a supervised learning, and that's a classification problem that we have looked at. And now we are going to look at K-mean clustering. So K-mean clustering is a type of unsupervised learning. Okay. So in the previous examples that I have given, so when the cluster is not marked as class A or class B or something like that, when we are just given some kind of data with no labels at all, then we can apply K-mean clustering to it. Okay, if you can see in this image here, the unlabeled data that we are having here, right? So this can be as a single cluster, this part can be as a single cluster, and this we can say as a single cluster, right? Looking at it, we can group some of the data points, right? So similar, but how will a machine do it? Like we are looking at it and we are making some inferences, so it's fine. But how will a machine look at it, right? So the what we have to do is for this unlabeled data, we'll apply k-means and then we are going to get this kind of clusters, right? They are grouped into different things. So k-mean clustering is a technique to partition n observations into k clusters. So n here is the total number of data points, and clusters means you will decide on k how many clusters you want. If I'm looking at this data set, I'll just say I want 3. But what if I say k equal to 4? Then this should be divided into 4 different clusters. Okay. So, so K-mean clustering is a technique to partition n observations into k clusters, in which each observation belongs to a cluster with nearest mean. Okay. So if I'm having if I'm taking some random data points, I will find the mean of it. And then I'll take some other set and then I'll take the mean of it. Then I'll take some other data points and then I'll find the mean of it. Okay. So I'll do all of this and then I will try to partition the data and we will see how we are supposed to do it and all of that. Okay. Is K-mean clustering clear? Like I'll tell you the procedure to follow, but so far as a whole, like what we are going to do, is it clear? We have unlabeled data and then we apply k-mean clustering to it so that it is going to cluster up, it is going to assign some class to each of the data points. Okay, um, I'll continue. K-mean clustering algorithm. So the first thing that we are supposed to do is first you need to select the number of clusters that you want to have. So here K represents number of clusters. Yes. Here it is number of clusters. In KNN, K represents the number of nearest neighbors that we want. Okay. So here let's say this is the data points that we have. This green dots. Okay, they are unlabeled. We have it. We don't know which class they belong to and everything. And now I'm looking at it and I'm saying I want to divide all of these data points into K clusters. Okay, for example, here I'm just saying let us say k equal to 2. Then I might say maybe this is one cluster and this is one cluster, for example, right? Yeah. So what we have to do is we choose k random points. If I'm saying k equal to 2, I have to take two random points. Okay, these two random points I call them as okay okay, here if you see, this is one random point and this is one random point. Since I'm taking k equal to 2, I'm having two random points here. If I say k equal to 3, maybe I'll take another random point and I'll put it here or here or here. It is up to us where we want to keep. Okay. So these points can be like randomly you can give some value and you can put, or you can convert one of the data points or which are already existing into a random point. Okay, either that or this. You can do anything, but here I have additionally added 2 points. So if you see here, this blue, there is no point here, but here I have added blue. And similarly for orange, right? So then we are going to assign the data points to this scatter plot. So this is the scatter plot that we have to its closest k point or centroid means. So now what we are going to do is we are going to assume this blue and this orange, the ones that we have just added, okay, them to be centroids. Assume these to be the centroids, okay, added centroids. We are adding it by ourselves, right? So this line which is there in between both of them is called as the median between both of those centroids. Okay, this one the PC will calculate for you. The if you write a code, it is going to calculate it for you, right? So now what I'll do is based on the median between both the centroids, I will draw the line, and the one above that line is a one cluster, and I'll say the one below that line is another cluster. Okay, it's just I'm just saying I'm going to have the median and I'm going to divide both of them. Okay, but then we need to find the closest cluster. Closest cluster means something like this. It should be closer. The point should be closer and it should divide like this. Okay, so in order to find the closest cluster, what I'll do is I'll repeat the process. Now I'll take a new centroid point. So from this blue point, I'm going to shift to another point, and from this orange point I'm going to shift to another point. Okay, and then again the same process will continue. Again I'll draw a median line, and then I'll try to divide it again, and then the data points keep reassigning to the new ones. So if I am shifting the centroid from here to here and from here to here, I have the median like this, right? So above that median line, now I have one orange, and below the median line, I have two blues. Now these data points, they will shift their color, I mean, they shift their class to a different one based on the median line. So this orange one will turn to blue, and these blue ones will turn into orange. Okay. So like that, this reassigning of data points to different clusters keep happening. Okay, it keeps happening and we have to keep repeating until and unless we come to a final proper cluster. Okay, okay, and once we find the cluster, we just have to remove the centroids. This is the overall step, overall procedure. Is the procedure clear so far? So first we select the number of clusters that we want, and then we select k points at random, and then we make a cluster. Then we draw a median line using both the centroids, and then we make the cluster, and then we compute the centroid of the new cluster, and then we shift it again, and then again we will draw the median, and then it keeps on happening and happening and happening. So we keep repeating the same procedure until we get a proper cluster, something that looks like this, right? This is exactly dividing in between, and then we are having two clusters. Yes. Okay, cool. So now this is all okay. But how is a machine going to know this is a proper cluster or not? So we are looking at it and we can say, okay, this is exactly dividing both the clusters. So this is a good cluster. Like this is a good division of both the clusters. But why not this is a proper cluster? Why is it not? Like if we are looking at it, we can say this is not a proper cluster. But how will a machine know? So for that, we use something called as WCSS. Okay, this is to assess the quality of cluster that we want. I think it is within cluster. I'm sorry, I forgot the full form. It's within cluster something. Uh, okay, but this is the formula. So it will take the distance between each data point and the cluster centroid, and then it is going to give the quality of the cluster that we want. Okay. Uh, sorry, within cluster sum of square. Okay. Okay. So based on this, we assess the quality of the cluster, and finally we come to a conclusion which is good and which is not good, right? So here we will look at the R Studio. Okay, just a second, I will stop here. Okay, I'll clear everything from previous. Okay, so this what do we require? Just a second, I'll open Q&A. Yeah, centroid means mean here. Yes. Okay, so for K-main clustering, so these are some of the just need to delete this. Okay. We initially set seed for reproducibility, so this is a common practice. And then we load some libraries that we want. So the library that I'm first loading is ggplot2. So this is basically for graphical plotting in 2D, right? So first I'm loading that library. And then I am going to another library, Mars. So in this, what I'll have is this K. Uh, all the necessary functions that we need for k-mean clustering. Okay, so for that we go for mass. And now I'm taking 150 data points. So 150 random data points I'm taking right now. Okay, so n equal to 150. And then I am saying center is equal to 3. Center here is nothing but the number of clusters that I have. Okay, so I'm taking 3 different clusters. Okay, and then here I'm declaring radius because I want all the clusters to be at one particular place, right? So here one cluster, here one cluster, here one cluster. Like that, I want to divide things, right? So for that, I will give some radius value for every cluster. Okay. So now what I'm going to do is I'm creating some random clusters here and there in circular patterns. For that, I also need the theta, that is the angle between. So I need it from between 0 to 2 pi, right? And then that is an angle in radians. And then I'm going to take cluster centers. Okay, this is all like this is only for generating the clusters that I want. So this is not of interest for you, but I'm just explaining. Okay, and then you generate some data points around the circular cluster centers. Uh, you write that in form of a matrix. Yeah. And then here, what I am doing is I am putting it everything in data points. And now I want to plot and I want to see how the data points look like before I'm applying k-mean clustering to it. Okay, so this is how my clusters right now look like. Okay, so if you directly see, we can just say, okay, this is one clutter, this is one cluster, and this is one cluster. Like we can directly say, right? Want me to scroll up? Okay. I will share the code with you later. You can experiment with the code however you want, and if you are interested, you can go deep into it as well. Okay. So yes, if I'm plotting the graph, so this is the three clusters that I am able to look at. So this is one, and this is one. So if I look at it, I can directly tell, but I'm not sure if the computer will do its calculations on its own, right? So now I want to perform k-mean clustering. So k-means is a function that is from the library mass. Okay. So what I'm saying is k-mean open bracket, and I'm saying data points comma 3, right? Want to know more? We'll see what other things we can give in k-means. Defined. Okay. So for k-means, we can give what is the value that we want to give, and we can also give the centers and how many times we want the iterations to happen. So if I am going to increase the iterations, the computation will increase, but we are may most probably we are going to get to the best output. Okay. There are other algorithms also which you want to give. That is not of necessary for us right now. Okay. Um, yeah, go back to the plot. So this is the overall plot that we see. And then now I am applying k-means to the data points, right? And then I'm saying my k equal to 3. And then I'm saying for 10, do it for 10 iterations. Okay. Now I'm printing the results. Okay. So it has done the clustering, and then it is saying in one cluster there are 32 points, in one cluster there are 18 points, and in one cluster there are 100 points. So it has clustered everything together. If I'm adding everything up, I should be getting 150, right? For all my 150 points, it has clustered into three different clusters. I mean, it has divided into three different clusters, right? So, based on the data point, my first data point is in the cluster 3, my second data point is in cluster 3, and so on and so forth. It is all divided into threes, twos, and ones, right? It will just give the cluster names as 1, 2, 3 rather than ABC. Okay. And then it is also calculating the WCSS. Okay. For each cluster, what is the WCSS values for the final one? Okay. So for cluster 1, it is this value, cluster 2, it is this value, cluster 3, it is this value, right? And the total is 46.1%. Okay. So far clear? Okay. So now I want to look at it. I want to see how it has divided and everything. So first I'm going to extract the cluster assignments. So how it is this vector which is there, this clustering vector, I'm going to take that value first. Okay, and then I'm creating a data frame so that it will be easier for me to plot the graph. Okay, and I'm plotting the graph such a way that one cluster is red in color, one cluster is blue in color, and one cluster is green in color. Okay, I'm giving three different colors to it, right? And then I just want to plot it. Okay, and then I have plotted it for this particular problem. So it has clustered this way. So it is saying this green side, this all is one cluster, and this blue part is one cluster, and this red part is another cluster. So that is what the the iterations has come up with. Maybe if we increase Some values maybe it will differ. See what we can increase is, let us say the iterations to be 20. Okay, and then let's see if something has increased or not. Now, when we have increased the iterations from 10 to 20, now it is saying this whole part is one cluster, this part is one cluster, and this part is one cluster. Okay, so we have to come up with an algorithm which says try different iterations, and whichever is giving you the best WCSS value, that will be the final cluster for us. Okay, but here I haven't done that. I'm just giving manually. I'm trying for different values. Let's see if it is anywhere closer. Um, yes, good. When I have given for 15 iterations, I will share the code after the class is done. I will share the code. I have to upload everything at once. Okay, I'll do it all at once. So when I have kept the I have changed the iterations from 10 to 20. It has given a different kind of clustering. When I changed from 20 to 15, now it has given this kind of clustering. So the proper clustering that we wanted is at iteration number 15. Okay, so you can manipulate this code into writing it in such a way that take the highest value of WCSS code. Okay, and then that make that one as the final clustering. Okay, and then that will be easier instead of trying different values here and there. All of that. Okay, so far clear. Sharing this one. Open this. Okay, so we will go back to the discussion. Any questions so far? Anyone has any questions so far? Okay. Cool. So since there are no questions, okay. So I'll only ask a question. How are we going to choose the k value? So in that code, I just took k equal to 3 and I made 3 clusters. So that is why I was taking k equal to 3. But in case if I am going to give you a code, in case if I'm going to give you a code, I mean, sorry, not code, if I'm giving you some data points, okay, and I'm not telling you how many clusters are there in that, then how are you going to choose the k value, right? So that's a question. Will you provide any more sessions? Yes, I will provide one more session next week. You will be getting the details shortly. Okay. Yeah, you and if you want me to cover anything in that, so please let me know beforehand so that I can cover everything. Okay. So Kanchan has already asked. Kanch, I'm sorry if I'm pronouncing it wrong. Sorry, something went wrong. Um, yeah. So Kanchan has already asked to cover some topics, right? So I'll cover those topics, and if you also need any other topics, if you let me know beforehand, I will prepare all the material and then I can discuss. Okay, right. So, how to choose this k value is an important question that we have to ask in k mean clustering, right? So, what you have to do is you have to plot a graph between WCSS and number of clusters. Okay, so you have to randomly take k equal to 1, 2, 3, 4, and so on up till some numbers. Okay, and then you take the WCSS value as well. Okay, and exactly where you find this bottleneck. So this is called as a bottleneck. So where you find the drastic shift suddenly, like an elbow, like how we have this shift, right? Some angle. Sudden shift will be there. That is the optimal number of clusters that you have to take. Okay. So this is called as a bottleneck or an elbow point. And whatever is the k value, you have to take that. So this is k. Okay. So that is how you choose the k value. So first you have to do this process, plot all of this, and then you have to finalize which k value you want to take, and based on that you have to go proceed, right? Okay, so let's get back to some questions. What is the primary objective of k-mean clustering algorithm? What were we doing so far? Is it classification or dimensionality reduction or clustering or regression? C. Yes. So far we were doing clustering. So clustering is the right answer, right? Okay. How does the k-mean algorithm initialize cluster centroids? So yeah, any guess? Yes. So we are going to take it randomly. Okay. What does k represent in k-mean clustering? What does k represent in k-mean clustering? Is it the number of data points or number of clusters, number of features or number of iterations? B. You're absolutely right. What does k represent in KNN? What does k represent in KNN? K nearest neighbor. Yes. K in KNN represents the nearest neighbors, and K in K-mean clustering refers to number of clusters. What is the objective function that K-mean tries to minimize during clustering? What is the objective function that K tries to minimize during clustering? This WCSS is called within cluster sum of square. differences. Okay, so the answer is A, sum of square differences between data points and the centroids, right? This- What is the key assumption made by k-mean clustering regarding cluster shapes? What is the key assumption made by k-mean clustering regarding cluster shapes? This one is easy to answer if you think from the R studio perspective. Yes, you're absolutely right. So the assumption, wait, sorry, that's not the one. The answer is B. So we generally assume that clusters are spherical and are equally sized. In the R studio, if we see, when we were declaring the data points in form of clusters, we were taking it in a circular manner like this. We had different data points here and there. We were declaring the radius, we were declaring the angle and everything, right? So we usually generally assume the clusters to be spherical and equally sized in nature. Okay. What is the role of the elbow method in k-mean clustering? What is the role of elbow method in k-mean clustering? Okay, one person thinks A. Anything else? Not of equally sized because size depends on number of data points included. No. That's not the size that we are talking about. The data point size. Okay. Uh, Sorry. Okay, so everyone are thinking it's A, but no, it is to compute the final cluster assignment. Okay, so to determine the elbow method is used to find the optimal number of cluster K. Okay, so hence we take which is a final K value that we want. Oh, sorry, you guys are right. It's assignments and this is number of clusters. So sorry, you are right. To determine the number of clusters. So the final number of clusters that we want to take, we use the elbow method. Given a data set with 100 data points, if you perform k-mean clustering with k equal to 5, how many cluster centroids will be initialized initially? If I'm having 5 clusters, like k equal to 5, what are the number of centroids that I have to take initially? Remember the example that we were taking when we have started k and n, right? There we have taken two centroids and then we got two clusters, right? So here I'm saying my k equal to 5. So how many centroids I should take? Yes, you guys are absolutely right. It's 5. Okay. Okay, so this is the last question for today. So you are comparing the performance of two k-mean clustering solutions. Okay. Solution A has WCSS 800. Okay, and solution B has WCSS of 700. Which solution is likely to be better? Yes. So the lower the WCSS value, the better is the performance. Okay. So yeah. So with that, we can. I finish whatever I have prepared for today. Okay. So yeah, we are a bit early today. So with this, we are done with the class. Okay. So with this, we are done with today's class. So we have covered almost everything, right? So all the notes will be uploaded on Drive, and also the video will be record. The video is being recorded, right? So this recorded video will be posted on YouTube, and all the links are available on NPTEL session, right? And please don't ask me any questions regarding the exam. I have absolutely no clue. I'm not the one who is setting up the paper. I'm not the one who's doing anything. But all I can say is prepare well from the material that is being provided and prepare well from the assignments. Okay. And yeah, please repeat question before elbow method. Yeah. So basically, clusters, we assume them the basic, that is the basic assumptions that we usually make, that they are spherical and equally sized, like roughly like not exactly, like I don't say it is 50-50-50 like that, but it's roughly equally sized. Okay. So that is a textbook assumption, we can call it. I need explanation about WCSS. uh, WCSS has its own formula. You just have to take the distance between the data point and the centroids, and then uh, the closer the values are, the better the clustering is, right? So hence the WCSS value will be as low as possible so that the distances between each data point and the centroid are uh, less. So hence we take less WCSS value. Yeah, equally sized in diameter, I guess. I'm not sure. I think it's cluster sizes. The clusters are equal in almost in number. So let us say if I'm having 150 data points, it can be like 48, 52, and 50 in that way. Okay. Anything else? There is going to be another session, extra session that I'm going to take. Okay, it's basically I was thinking to give a quick recap of everything, like not too deep, just some basic formulas and how to approach what and all of that. Okay. That will be scheduled sometime next week, but not particularly sure if it is going to be on Wednesday or Friday or not. So we were asked to do it before 18th. So I don't even remember what time I have given. I have to check with NPTEL again. Okay. So you will get a mail shortly regarding that. As far as I remember, I have given on Tuesday. Okay. So in case even if you miss that, the lecture recording will be available, so you can always have a look at it in case you need. Okay. So yeah, with that we are done for today. Okay. Have a great weekend, everyone. I'll just stay till 8, but you guys are you guys can leave if necessary. Okay. Thanks everyone for joining, and you have been a real amazing students throughout the entire session. And I had lots of fun teaching you guys. And seriously, without you guys, I wouldn't even be able to prepare for the questions and take the discussions longer. So yeah, thanks for helping me out as well. So thanks everyone for joining, and bye. Thank you so much.